Gentlemen, we are taking a look at activity 1.1.4, which is targeting success using data. As we're going through this activity, you are going to take, here's our materials, you're going to launch your launch device from 1.1.2, beanbags, and this says printing graph paper. There's another video that goes over how to create your target. But you are going to test your device. So if we scroll down here, we're going to prepare our testing station. You're going to set it up. We are going to have our quadrants. So where those pages intersect are your XY axes. And we're going to take that device. We're going to measure the distance between the device and the coordinate plane. And you're going to launch that beanbag at the target, and you're going to record your X coordinate and your Y coordinate to the nearest 0.5 of an inch. If you want to go centimeters, go for it. But inches are where we're okay with. And you're going to record that in a spreadsheet. All right. If your bag does not hit the ground, record off grid in the table. Okay. That's important because it's data that determines how this device is reacting. All right, and we're going to follow through. You're going to create your spreadsheet. You are going to include the spreadsheet in your engineering notebook. What this does is it gives us a chance to evaluate precision and accuracy. And we might think that they're the same thing, but accuracy, if we take a look at it, accuracy is the degree of closeness of measurements of a quantity to the actual accepted value. What would be the value that you would want this to hit? So how close are those to what you would define as being where you want it to end up? Precision is the degree to which repeated measurements show the same result. They show the same result. So if you have a ruler or your micrometer, they're set to a certain precision to get the same result every single time. So if we look below, if your launch device is accurate, your grid would show beanbag landing locations evenly distributed around the center of a target. If your launch device is precise, repeated launches would be close to each other. So if we look further down, right here, we have things right around one spot. So this would be precise but not accurate, because when you have a target with a bullseye, that's typically where you want it. This one, if we look at it, we have all the results kind of scattered around that center. So this would be accurate but not precise because things aren't ending up in that same location. If we scroll down, this one right here, neither accurate nor precise, because if we look at it, it's all kind of scattered but spread out, and it's not near the target. Here would be accurate and precise because we're right around that center of the target, which is typically thought to be our intended goal. Okay. As we go through this, we're going to have a question. We're going to talk about the discussion questions as a class. And you want to start thinking about what your standard is that you're going to compare against. Because our standard, it's something established by authority, custom, or general consent, is a model or example. Or set up and established by authority is a rule for the measure of quantity, weight, extent, value, or quality. As the designer, you are the authority on this design. So what is your rule? What is your general consent that your goal is for this device? Okay. You're going to keep going and working with this device. We're designing with data. And there's going to be more information here where you're going to have a spreadsheet and analyze that data. Okay. If you click on these plus signs in the assignment, it will give you the formulas to use. Okay. There is also a template that you can use. As we go through this, ask the questions that you have.